Next point is relation between analog and digital frequencies. So we know omega is equal to omega t, and for 2 pi by t strip in S plane, that is varying from minus pi t omega to pi t, will give minus pi omega to pi. Now this is very interesting point. If it is a imaginary z and it is real z, and it will plot j omega with sigma. So we are going from minus pi by t to pi by t. So we are splitting this region. So we are marking this region as this, and similarly this to this. Now we know the unit circle. So this is our unit circle. Now this is 0. Now if we go from 0 to minus pi by 2, that is at 0, that is omega, omega is equal to omega t. At omega tends to 0, omega will be 0. So it will at this particular point. Now if we move towards 0 to minus pi by t, so if we substitute minus pi by t, omega will be equal to minus pi. That means it will go from this point, it is minus pi by 2, and then this is the minus pi point. So we'll mark it like same. It is this, the whole part which is covering from 0 to minus pi by 2. Now if we start from 0, again we are at this point and move towards pi by t will be equal to omega equals to pi. That means we go to pi by 2 first and then go towards the pi. So the shaded region will be marked like this. Now in a similar manner, if we move towards the point, that is j minus pi by 2, j 2 pi by t, then it will go from minus pi to 0. In the same manner, it will be like this. And if we go from minus j pi by 2 to minus j 2 pi by t, then the shaded region will be like this. So we can clearly see this is many to one mapping. That means this mapping alone covers the complete unit circle. And now as the frequency repeats, as the frequency increases, this follows a periodic phenomenon which we have already seen. This periodic phenomenon we have observed with the sampling process. That means whenever we digitize this frequency, it follows a periodic phenomenon, and that's the same kind of phenomenon we used in DFT previously. From these points, we can have some observations. First is one-on-one mapping is only possible if omega lies from minus pi omega to pi, and required condition is omega lies from minus pi by t to pi by t. If this range of omega lies from minus pi by t to pi by t, then only omega will lie from minus pi to pi, and one-on-one mapping is possible. Second point is sampling process. Of impulse response leads to the periodicity in the sampled signal. At a multiple of omega s is equal to 2 pi by. Now there is a sampling process, and the required condition for no aliasing is omega s should be greater than twice of where omega h is the peak frequency. Component. Now that's mean the signal should be band limited. Now what does band limited means? That it should have value 0 above a certain frequency. In this case, that is the highest peak frequency, that is omega h. To avoid the aliasing effect. So, what is the case? If we see in the analog domain, magnitude of HAS, or we can say H omega t, is like this, going from minus to t. Now, if we move to digital domain, it will be like this, minus t to t, h omega t, and then there is another periodic signal which will come again, and there is another periodic signal at this side also. only condition to avoid aliasing is to make t very small. This particular condition we have already used in our previous case to approximate the DC gain. So we have used this condition. So we have seen why this condition is important. This condition is used to avoid the aliasing. Keeping following point in mind, we can conclude impulse invariant method is suitable for low pass filter and band pass filter where stop band overlaps and effect of aliasing is minimum, because we are much interested in pass band. If it is not suitable for high pass filters and band stop filters where pass band overlaps, thereby magnifying the ripples and leads to distortion. Now we will quickly go through the advantages and disadvantages of impulse invariant method. So advantages and disadvantages. So advantages, first is it preserves the stability of the filter. Second, relation between analog and digital frequency is linear, that is omega is equal to omega 2. Third is due to linear relation between analog and digital frequency, specifications of digital filter can be achieved easily. Now we have seen the advantages of impulse invariant method. Now we will see the disadvantages. So first disadvantage is z equals to e to the power st does not describe one-to-one mapping. Second is analog filters cannot be band limited, thus causing aliasing. We cannot band limit analog filters. That's why there will be aliasing effect always present with the impulse invariant method. Third is, this method is not suitable for designing high pass filters and band stop filters. That's all with the impulse invariant method. We'll discuss another method of IR filter design in next lecture. Thank you.